Yeah, so I've been a ham for probably as long as I could drive, if not longer, when it was the cool thing to do in high school. And of course, we were by far the first social interaction stuff going on. So I will go over a couple of things. First, I'm going to hit what's an SDR. Now, I've only got a few cameras here. So I like seeing people's faces. And I want to know how many people actually own an SDR radio. And I can't see this, so I'm assuming most of you are saying no, and a couple might. Yes, Kevin, you don't count.
Well, does one of these little guys count?
Yeah, that counts.
Okay,
But I
well,
bet you
that's an SDR.
I'd be really surprised if not everybody here owns an SDR radio. Here's my other one.
Yep.
iPhones, Androids are all software-defined radios. Hello, everybody in the room. Can you hear me okay?
I hear you great.
Okay. So that's what an SDR is. We're going to go over some terms you may not have heard, and some of the products. Yeah, there's a bit of advertising in here, and what we can offer for you. So it is a radio, a software-defined radio. SDR, software-defined, is a technology. It's not actually the radio. It's how the radio is built. And if we back up to spark gap days or tubes, and then we had transistors, and then surface mount, and then, a whole bunch of things. Things got smaller and tinier, and software-defined technology is where we're at today. And what that really means is, instead of having all those coils and transformers and mixers and stuff, we can now direct sample, which means we come right from the antenna and then we digitize it. And by making it direct sampling, it's quieter. When you mix two signals, like we were all taught forever ago, and eventually get down to IF frequencies, mixing signals is noisy, and then you have to add filters to clean up the mixing. Software defining, or direct sampling rather, makes that a lot easier in the long run, and a lot cleaner and quieter. It also means that if we ever came up with a new mode to replace upper sideband, lower sideband, AM, FM, or some whiz-bang mode, you wouldn't have to buy a new radio. And if you've been around long enough, and you had your Icom 753 and the new bands came out, yes, I used to own one. And if those two people have ever owned one, you chased me across the band because they all drifted hugely. All this stuff is built in, we can build in a new mode. And we actually call those waveforms. That's the software term. And we're actually doing that today in our commercial business for the US government. The flyboys are all putting in new radios, and they're using waveforms. So those waveforms could be used for decoding digital data, talking, or some encrypted mode for the Air Force. And so even though you might have an RTL dongle, that's sort of what we stamped it with, but it's still just a manufacturing way to build it. And I don't know if you know what those were for. Those were originally TV receivers in Europe, or where you could just plug it in, hook up an antenna for TV channels. So and that brings the radio today is really future proof. Even Icom with the 7610, and we'll probably see the same thing with the Elecraft K4, that it will have the ability to be upgraded. And hopefully, at least this is what we hope, that if you were to buy our radios, that it has a long-term lifespan. Case in point, from those in the room are HF operators. How many people have actually owned all three 756s from Icom? If you were an HF person, because that was sort of the mid-consumer grade radio. You buy one and it was great, and then they came out with what was called the Icom 756 Pro 2. Well, you sell the Pro, the first one at a loss, you pay full price for the new one, you get a new radio. Then they came out with the Pro 3. Guess what? We did it all over again. And in today's world, even with our Flex 6300, which came out in about 2013, it's still a really good radio, and it still runs the current software we build for the radio. All our radios have multiple receivers, not just sub receivers, but they have multiple receivers. They like having 2 receivers on your desk, or 4 or 8, depending on the model of the radio. And some models of radios can use 2 different antenna paths at the same time. How many in the room, or put their hands up, actually are on HF and are doing digital mode operation? Okay, a bunch of you. You know how if you're using today's superhet radio, you're locked into doing one thing at a time. We have one serial port, so that's our cat control. While in the world where we're LAN based, or we're using the Ethernet in our house to communicate to the radio, we can have multiple things doing multiple decodes at the same time. And I'll show you a bit of a picture about that later. And we have these helper programs that are part of the radio that allow all our normal programs we like to play with, WSJTX, Ham Radio Deluxe, N1MM, FJ Logger. My brain is going tonight. It's been a long time. All these things going where you can actually all share receiving information. You can share the transmitter and the frequency information and mode from the radio all at the same time. No more conflicts. No more, I got to shut down this logging program to bring up, WSJT and these port conflicts on RS-232, which is an incredibly old technology. Digital audio exchange is just the tool we use to get the audio from the radio into our, WSJT program. If you're doing digital now, odds are you've either built your own hardware interface, or you've bought a Rig Expert or Signal Link or something like that. Not required anymore. We get rid of a lot of hardware. And feel free to change. So the radios are all built and designed in the US. We do a little bit of offshore stuff, but I think it's just our metalwork. Cabinets come from offshore. Engineers are in Austin, Texas. Our tech support's in the US. We ship out of the US, and like everybody else, we're having a few problems getting parts from time to time. It comes and goes. This week I thought we were going to be in a 3-week slowdown, and it was for a trivial part. I won't say what it was, but it would not prevent the radio from operating from any way. But it's like buying a car and we can't give you the rear view mirror, so you have to wait for the rear view mirrors to come in. So we also have a repair and help center in Germany for our American or Europeans. And we actually talk on the phone to customers. We have salespeople, we have people like me. We're pretty active in social media. And all the radios come with a 2-year warranty included, which you can extend to 4 years, and a 30-day return policy, because we appreciate the fact you really can't try a radio by going into a ham store using their antennas, because most of these are shops, and a lot of them I've been in have been in some sort of urban area, so they're incredibly noisy. So it's really hard to get on 20 meters and give it a fair shake. So it's, you can have a radio for 30 days, try it on your time, your antennas, your 2 o'clock in the morning, because you're a low band worker person. And if it doesn't work well, we give you your money back. All you have to do is ship us back the radio. So a few misconceptions, in case you've heard any of them because you've been listening on HF or reading online on QRZ or something. I talked about where it is built. You don't have to be a computer guru to make it work. We've made it work fairly well on Ethernet. And I know this sounds a little overwhelming. Just bear with me a minute. We have radios that sit on a bench, like at field day. You don't have to be connected to the internet. You can drag an M model, we call them, to a picnic bench, hook up a battery, throw up an antenna, and be on the air if you really wanted to do that, or certainly for a field day situation. The software does not expire. There is no annual license. And if we went away, your radio would still continue to run. Yes, we do charge for major software updates. That just helps pay staff bills, and it's $199. And like I heard a guy from an OEM vendor say at a virtual Hamfest going, it's impossible to do CW if you're interested in remote operation. Nothing could be further from the truth. We do CW. It's hard, by the way. Doing CW over the Ethernet or the internet is hard to do well. It's not trivial by a long shot. And I've tried even sending CW in with just basic logic from a key across my network in the house, and it was really weird because your Ethernet sort of slows up and speeds down, slows down and speeds up, slows down and speeds up. It's quite funny. All right. So first thing, spectral capture unit. This is a couple of terms we're going to go through. This is actually what the antenna connects to. It's how we digitize, where we turn the analog signals that are in the ether out in the air into digital numbers so that we can do something with it. And by the way, unlike an RTL dongle, we actually digitize the entire HF spectrum from 30 kilohertz to 54 megahertz simultaneously. So you can, if you want to zoom out in the pan adapter, you can see the whole spectrum, the HF spectrum at once. And some radios have 2 spectral capture units. That's the part I said earlier, where you get to operate on 2 different antennas at the same time. It's like having 2 radios on your bench, and you just share the transmitter. So a few more terms. The field programmable gate array. So before we would talk about mixers and stuff, this is just sort of like the computer where everything happens. This is where we do all the number crunching. And for the geeky people in there, when we take that analog data from the spectral capture unit and we have to digitize it like we do into a computer, and we move it over the field programmable gate array so that we can now analyze the numbers that we've created, we create 4 gigabits of data. Now, that doesn't sound like a big number, but think about it this way. Most homes have a 100 megabit network. Some of us have gigabit network or 1,000 megabit network. This is 4 times that. That's a lot of data. And it's like having, I think the number was 340 Raspberry Pis running in parallel. So it's a lot of horsepower going on within the radio. The client is the part you and I use. CAT, as I mentioned earlier, replaces RS-232 stuff. And DAX, digital audio exchange, is how we move the digitized audio around. Now, you don't have to worry about the fact it's digitized, but that's how we get the audio from the antenna through the radio, out of the radio, and into WSJT as an example. So it's called DAX. Talked about the field programmable gate array, and that is the where we do all the math and we load new software in from time to time. And the other way I put it is your brain, that's your FPGA. Your eyeballs are your spectral capture unit. Make sense? Your mouth is the antenna, but we won't go there. So there's different types of models of radios, and they're into 2 different lumps: the 1 spectral capture unit or the 2 spectral capture unit. If we back up all the way to 2013, this Flex 6300, 6500, and today's 6400 have 1 spectral capture unit. So that means you can only use 1 antenna at a time, and it's got a 2-port antenna switch on the back. But it doesn't prevent you from listening on 160 and 10 meters at the same time if you were using a common antenna like a G5RV or an HF6V vertical or something like that, a multi-band antenna. So that's pretty handy. And actually, if you were a contester, you could be on 20 and 15 at the same time if that was something you needed to do. Pretty versatile. We get to other radios with 2 spectral capture units. In the first release, it was the Flex 6700, and in today's world, it's the Flex 6600. And I want to make this really clear. You're not limited to having to stay on 20 meters with these slices or receivers. You have the versatility to move around the HF spectrum. And on the shot on the left, that is actually 2 slices, one above the other. The bottom one's on 7154. The top one, I guess I compressed the picture, so it's a little hard to see where it is. But we are decoding. It's probably on 20 meters and decoding a whole pile of WSJT signals. So a bunch of radio clients. This is the part we use to be able to hear and talk on. The radio comes with shipped with Smart SDR. That's a Windows program. We also have the Maestro, which is a big standalone control head device that can connect to your radio while it's sitting on your desk across the house or across the world. Now just take my camera here, and there's my Maestro right now, and it's nice and big. It's got an 8-inch display, and it's got the key buttons we need, the stuff we use all the time. And to reference buttons, I counted the buttons on the front of an FTDX 5000, I think I got to 118, and each had multiple levels of shift. And some of them were 2 levels, and some were, let's see, press and hold, a function key press or press and hold, like Yesu's really good at. So we also have apps that are run on iPhones that you could use, connect to your radio over your iPhone or your iPad, or also another third-party product from another Apple developer, from Dog Park SDR. And if you have Mac users in the crowd, I'm sure you may be using his logging programs, and if we have satellite users, his satellite program. So again, this is the Windows client. It works on all our radios. It's free, and you don't need a super powerful computer. If you paid attention to us or were watching us back in the Flex 3000, 5000 days, you need a really good gaming machine to do anything. Not today. All of our computers need something called a thin client, which just means most home computers. Now, if you start adding a lot of digital programs that using and actually running them at the same time, you may need a fair bit of horsepower to make that happen. Okay, so here's the part about the radios. All of them, and I actually pulled these numbers, some of them from Rob Sherwood presentation. All of these radios are contest grade radios. So what does that mean? Even though you're not a contester, it means that you won't suffer from AGC pumping. Have you ever been on HF and you had your noise blanker on and the guy 10 kilohertz up, seems like he's splattering? Those days are gone. It doesn't happen because of the way we handle the radio. We can look at very specific narrow frequencies measured in hertz and make a very clean receiver. Also, case in point, today and Kevin, what state are you guys in? I apologize for not checking.
Georgia.
Okay, so you have your share of thunder and lightning storms on
Oh,
HF.
absolutely.
So this morning, I was on 80 meters about 8 o'clock on a local net, and I was, gabbing on about something about sunspot cycles. And the net controller said, I really had a problem hearing you because we have some thunder and lightning storms coming through. They were about 300 miles away. All the lightning strikes, and there was a lot of them, took you right out. And I think I have a demo of that coming up. I didn't hear it. So if at the end of the presentation, in this presentation, if I don't have it, I'll play it for you and I'll show you what it's like. So anyway, all radios have contrast grade receivers, so you will not hear splatter like you've heard it in the Superhet. They all come version 3 software. That's what we have today. And they have multiflex. And multiflex is the ability to have 2 clients use the radio at the same time. Well, why would I want to do that? Well, it means your buddy, if you have a friend of yours that's a shut-in, or 2 of you just want to share an HF station, you can both use it at the same time. You just have to figure out how to share the antennas. It's not really a showstopper. All radios have controlled envelope single sideband. Well, wait, what's that? Well, it's a technology developed by Dave Hirschberger, W9GR. It's published in QEX, and it essentially gives your signals, your SSB signal, an extra 3 dB, 2.8 dB output. Well, what's that if you're not a 2 dB conversant? Well, that makes your 100 watts sound like 200 watts and perform like 200 watts. Well, is it really 200 watts? No, it's just that we do it better, and superhet radios don't, to be blunt. So because of the way single sideband limiting happens, it's not uncommon. In fact, it's to be expected that in today's superhet single sideband radio, and even any other current radio, because there's only one other brand that takes advantage of controlled envelope single sideband, that it actually puts out less than its 100 watts to ensure that we're not overdriving the sideband envelope. And you can read about that on QEX. So here's the different types of radios. On the left, we have the 6400, but we have them with and without a front panel display. The top one means you have to use software or a Maestro. The bottom one comes with its own front panel, but you can also use a Maestro with it. It has 2 slices, and it has 30 dB bandpass filters, which makes it a great radio for field day operations, or if you're near somebody else. And it also has 1 transverter port if you're someone who's getting into 2 meter or above weak signal operation. And I will share this presentation with you so you can go click on the links and learn more. The 64M, the same radio, but it's got a front panel display. And this is where I said you can sort of operate in picnic table mode. We get up to the 6600. It's got 2 spectral capture units, so we can use 2 antennas at the same time, meaning we could be on 160 meters and 6 meters simultaneously. It's contest ready, so if you're thinking about single operator 2 radio contesting, and this means you could be on 2 bands at the same time. In a previous life, or if you were doing this before, you would have to buy 2 radios. You'd have to buy some sort of device to control the 2 radios. It's a fair bit of wiring integration, and I'll show you a slide about how that all changes. It's got 2 transverter ports, great radio for satellite work, and it's got 55 dB band isolation. It's a big number. And like the 6400M, the 6600M is the same thing, but with the front panel Maestro-esque display. Oh, as well on the M models, you can hook up an external TV if you choose, and that's pretty cool. And it's 1920 by 1080. And I know a lot of guys who are big into TV that took their 2K HD 43-inch screen just because they could, and they mounted it on the wall above the shack and fed the radio into it. It was a big display. I have to admit, it is impressive. The 6700s now, this radio has been around since about 2013. It has 8 slices or receivers. We're still building it, although its end might be in sight. And it is still in use by the US government in a lot of cases. And ultimately, what will probably stop us from building this is when we can't get whatever parts we need. Because in the electronics world, the parts inventory sort of rolls over every 8 to 10 years. So we expect that to be coming. I'm not pre-announcing anything yet, but we're preparing for it, and we've stockpiled a whole bunch of stuff. So very great contest radio too. So the Maestro is the one I was talking about. If you look on the picture on the left, you'll see all the ports where you can hook things up to. This is essentially an HF radio type of stuff that we would hook up on the back of the radio. We'd hook up headphones, external speakers, microphone, push-to-talk switch, CW key, line out maybe, and we can have that on our desk. And we can take the radio and we can put it somewhere else. We can put it under the desk. We could put it, behind you on a rack. You could put it in a whole other room. As some people do, like I do, you can mount it at the base of a tower. Instead of running 9 runs of feed line in, you can put all your antenna switching and everything at the base of the tower, less RF loss, more performance, and just run a single Cat5 cable. So this thinking about this moving forward, about what we're calling the LAN and the ham shack, this is where we're headed. At least we'd like to think so. But we have such an incredible user base and install base that it keeps growing and growing that I don't know, for my HF friends there, how many of you have actually gone out and bought Heliacs and dragged it in because you needed better high band performance? Or how old is your feed line? Is it older than 10 years? Have you swept it for path loss yet? Because it just slowly gets worse, and you may drop it down and get both ends together and run it through a VNA, and you thought you only had 2 dB loss. You might have 12 or 15. And I've seen that so many times, at least in our world, where we've convinced people to drop their feed line off their tower, and we've swept it with, heck, even a nano VNA, and you can see how many dB loss at what frequency. And we never hear our own antennas go bad because they slowly just get worse. I see that a lot in the low band stuff, especially some of the people I hang around with, and they haven't touched their antennas in 30 years. They haven't inspected their TH6, only to find out that the balun blew out a number of years ago. So we do actually have to do antenna maintenance from time to time. This is a new toy, the Tuner Genius, which again, considered the tower type of thing, is controlled by the LAN for us, but you can also use OEM radios on it, either Icom type radios or Kenwood or Yaesu. This is an incredibly rapid tuning, up to 10 to 1 SWR. It's very similar to the HF Auto, and just built like a tank. And I don't know if you can tell the size there. It's actually pretty beefy. It's probably about 8 inches tall. In this model is the SO2R model. It's designed to work with the Flex 6600 and the Flex 6700. But there's also another tuner, we call it the 1x3. So it works with all the single spectral capture unit radios, and it gives you control of 3 antennas on it. It's a full legal limit tuner. It'll take a beating, and it does a wonderful integration to our hardware. And then the Power Genius, same thing. Expensive amplifier. It's a $7,000 amplifier built like a tank. Again, can be controlled by many other radios. Icom, Kenwood, Yaesu, Elecraft. Works incredibly well with our radios because you just plug it into the LAN. And in my case, mine goes to 2,000 watts because, but it does easily do 2,000 watts. But of course, it's limited to 15 dB gain, which is the US regulation. It also has two things: MEFA, which is called maximum efficiency frequency algorithm. And what this does is you'll look at it and say, well, heck, I could use 50 watts drive to get my full power out. But what we're doing is a number of things. We're dealing with the gain numbers so that we keep within that 15 dB gain limit so that you can still get full power out. And people tend to say, hey, I only have to drive my amp with, 22 watts to get full, to get my full, whatever my full power out. But that full power out can only be a 15 dB increase type of thing. So there's also built-in bandpass filters for my contesting friends. This is the only amp you'll need for a full SO2R station. Same thing with the tuner, by the way. Single operator 2 radio. It's also got a harmonic load isolator. So unless you're in the broadcast industry, you've never heard about that. And you remember in any amplifier we build today, say we build an amplifier for 14 megs and we amplify stuff, and we're going to have a second harmonic at 28 megs, correct? And every once in a while nod your head so I know you're listening. And then, so what do we do with that? Well, we have low pass filters in there. Well, what happens to that energy? Well, it gets caught by it doesn't get caught by the low pass filter. It gets reflected by the low pass filter back to the power amplifier. Well, we really don't want that. And so what happens to that? That can actually cause distortion and cause higher IMD ratings or worse IMD ratings. Well, that's not good. This is the only amateur amplifier that catches that reflected RF power with a high pass filter and sends it over to a dummy load where it gets turned into heat. Ultimately, this gives you a cleaner RF signal. And 403A, the designers did a great job of it. It's the only amp that we know of that does this, catch the second harmonic, deflect it over to a dummy load, and turn it into heat. Let's see, it can support 2 Kenwood radios at the same time. And by the way, if you see me looking up, I have to present from another screen above here. I have an ultra wide screen that I'm staring at. When I present for that, it looks really crappy, so you wouldn't be able to read it. So that's what the Power Genius does. Smart control is a cool feature. I'll just skip it right now because it's probably won't make sense until you've seen it in operation. But it takes your Maestro or your M model and give you some big knobs to play with. And you use Smart SDR on a PC to be your user interface. But when I send this around, you can go watch the video and look this. Flex control knob is a device. Let's see, how many people play with an SDR radio, SDR dongle of any type? Right. So as long as you're in focus, you're good, right? But if you're somebody like me that does 7 different things at the same time, if you go over to check your email, but you still want to dial up the band with your mouse button, you can't because your mouse is now scrolling through your email. Make sense? So the Flex control knob is always attached to the Smart SDR software. So like any radio with a VFO, it is dedicated to being a VFO knob, regardless of what you're doing on your computer screen. And it's got some hot switching buttons and programmable buttons. And it works on a PC and Mac for the Mac users. This is a cool feature. On the back of the radio, we have a USB port. We have 2 of them, or we have as many as you need. You can plug a RS-232 CAT cable in the back and feed CAT band data to a KPA 500 or some other band switching amplifier. Or you can put the parallel version, the 8-bit version, and you can say, every time I go to 80 meters, switch this bit high. Or there's relay boards that plug in that do the same thing, so that when I go to 80, energize my 80 meter antenna. There's a lot of functionality here, versatility, and you can, based on a bunch of different rules. If I have my transmit focus here, I want to, I want to be on this band. Pretty easy to follow, and we have some cool guys doing some really neat things with it. The transverter people, the weak signal people, really exploit the bit mapping so that they can switch through 7 or 8 bands and have them automatically, the right transverter be switched in line, and the right antenna selected. It's pretty slick. So I talked a little bit about, does anybody not of the visuals not know what SO2R is? You got an idea? Okay. So that's signal operator 2 radio. The contesters will be on 40 meters, say, running, working a bunch, but at the same time they might be dialing around on, they'll be literally be listening in one ear, but spinning the VFO on 20 meters, trying to find another contact or a new multiplier. That's what SO2R is. The RTTY guys do SO4R, but they're all nuts anyway. Because they take up a lot of screen real estate. I'm going to show you a couple of pictures. Let's see. Bear with me a second. Okay. So in an SO2R world, let's go back. In an SO2R world, if you're not using flex radios, you have to buy 2 radios. You have to buy bandpass filters. If you're a QRO station, you have to buy 2 amplifiers. You probably have to buy something called a station master to manage all this stuff, and then manage your audio. The SO2R operator listens to either 2 receivers at the same time until he's making a contact. Then he'll quickly change the focus to listen to just a single radio, and that's controlled by OTRSP is the protocol. Again, all of this is built into a flex radio, like a 60. Well, all the 6000 series do it. So you can even do it with a single spectral capture unit radio. And I know a bit of this sounds overwhelming. The point being, it's not complicated in our world. So how easy is it to do in a flex radio world? Well, let me just show you pictures. This is from Sierra Echo 3 X-ray in Sweden. And Jan, this was his SO2R setup. So if you take a second to look closely, and this is where the guys at home have an easier job than trying to look at a big screen. But I'll put my mouse up here, and you'll see that we have 2 radios, 2 Kenwood TS590s. He's got an amplifier here. I think he used to have another amplifier there. He's got this the Dune Star filters, rotor controllers, micro ham stuff. This is all to handle all the switching. Okay, and I get it. This is a work of art, and the geeky guys like Lee love doing this, especially when it all works. And then you come in and present it to your club, and you explain it to everybody, and they go, "Well, that's really cool, but it's too much for me." Unless you're dedicated. It's like any part of the hobby, right? If we really love something. Well, if you were to do it in flex speak, this is all it takes. I've removed I'm only showing what's required. 2 RF cables between all the devices and 5 LAN cables, and you're on the air. And you can set it up in half an hour. Go back to this one. How many custom cables do you think he had to make or buy? More than one. Go back to where we are here. I left out the computer for the logging, but that was sort of a common. So you have to buy 1 radio, 1 amplifier, 1 tuner, and the device in the upper right corner is a 2x8 switch by 403A, and what that allows us to do is control 8 antennas, but they can be shared in any of the receivers in the radio. So that's what a 2x8 switch does for you. It allows you to switch all this stuff around. It make it, one moment I want to be on 40. Maybe I have 2 or 3 40 meter antennas. I'll show you what this looks like in a different broadcast or a different screen share at the end. I talked about multiplex. So you could have 2 users in 2 different rooms or 2 different countries share all this stuff. And that's what we call multiplex. And I think I'm going to have to stop the share because I have audio to play in a minute. Cat. So again, replacing the hardware we used to buy with this program that comes with the software that allows you to share interfacing for N3FJP and all our logging programs. And there's no conflicts anymore. You don't have to shut down one and start another. You only have to configure it once. Make sense so far? A couple of people nodding your head. Okay, that means you're not asleep. Thanks, Mac.
Yep.
And DAX we discussed already. So again, digital audio exchange. This is what the user interface looks like. And these end up being sound cards and Windows control panel. So that when you go configure WSJT, you know how you pick down your audio source? You're going to pick it from here. And it's still, the setup's identical. And all hardware talks to each other. So we have, and this is as complicated as your network needs to be. We have some internet. Generally, we have a switch that's connected to our router, which is where the internet comes from. And we plug everything into a common switch and the stuff just works. It doesn't work so well when we get people who are doing meshes or range extenders, but we can help you fix that. And if you're ever installing a mesh, remember bridge mode. Believe me, your life will be so much easier. Instead of RF gain, we've got a tool called AGCT. The T means threshold. And you don't use the radio in the older HF world where we would maybe turn off our AGC. We'd turn the volume up full and use the RF gain to go up and down. That's the old school method. Doesn't work in an SDR designed radio, whether it's K4, the K4 of the Icom series or us. We use a different technology, different algorithms than everybody else does. I think ours works really well, and I've used them all, except I haven't gotten the company K4 yet. We actually, yes, we do have one. And but this is the ability to hear weak signals and really strong signals at the same time. And that works incredibly well because we have so much dynamic range that works fairly quickly or fairly cleanly is what I mean. So it's called threshold. There's a video here showing how to set up mic gain. We can skip this because that was part of a different power. All right, I am just going to stop for a second because I don't think I said play computer audio. So I'm just going to bear with me a second and share screen and share sound and share again. All right. This is a wide noise blanker. It's quite a powerful tool. I have two stations. I have a very simple station here in the city of Toronto. I live in the north part of Toronto. And I have a remote station. It's about 100 miles away. In this case, I'm testing the wide noise blanker. It has the ability to get rid of really annoying line noise. And noise, unfortunately, is random by nature. And sometimes this works great. And some noises and other noises it does not. The guys in the meeting room, if you don't get any audio, just put your hand up and I'll set it up again. But I think we're good to go. So let me just play this. And I'm trying to remember what the conversation was. Yes, this is a net controller. And you're going to hear him. It's something I recorded for YouTube, so you'll hear me talking through it as well. Here we go.
WB2KAO here. Good morning, Barry.
Now, WB2KAO, we can barely hear. Let me turn the blanker back on.
Yeah, real good, Barry. Just got off the bike, and I thought, well, let me check in with you here for a minute before I go up and get in the shower. We got quite a bit of fuel.
You get the idea? You want to hear it again, or is that enough? Power static. And for those that are not familiar with a waterfall, so the top part's the pan adapter and the bottom part's the waterfall. The newest signal's at the top, the Lotus is at the bottom. The blue is noise, our background noise, the green are signals. And the louder they are, the more red, pinky, reddy it gets, like reading a weather map.
Oh, we were supposed to see a waterfall? because all I'm seeing is introducing Zoom apps, and I see you clicking different icons.
Oh, heck. Let's start that again.
Yeah, because we didn't see the other stuff.
So you heard it.
I heard it, but it looks like you were just hitting the Zoom apps and they were
Oh,
coinciding.
I get it. I see what happened. Let's try this again.
All right.
Thank you. How's that?
Much better.
Let's play it again.
Play it again, Sam.
WB2KAO here. Good morning, Barry. And
WB2KAO, we can barely hear. Let me turn the blanker back on.
yeah, real good, Barry. Just got off the bike, and I thought, well, let me check in with you here for a minute before I go up and get in the shower. We got quite a bit of fuel.
Okay. How's that?
Better. That made more sense.
Okay. Sorry. Now, here's the second one about lightning. Now, I apologize for the story. I recorded this quite a while ago. It's recorded here in Canada on 80 meters one morning. And it's a friend of mine from northern Quebec, Chad, and he's actually telling us a farming accident story. So it's really, and I wanted to re-record this, but I haven't found a good storm to do it on. Each one of those horizontal bars that we can see is a pretty loud lightning strike. And what I want you to pay attention to is how, even though with those lightning strikes happening, that we have no problem following the dialogue. Okay. And this is the power of the AGC in the radius. By the way, I'll explain the automatic gain control. We have several. There's the one we've grown up with: fast, medium, slow decays, whatever. But in the flex radius, we have a fast attack automatic gain control, and it attacks in about 10 milliseconds. So it gets the lightning strike, it mutes the receiver or reduces the gain by a whole pile, and then immediately releases it incredibly fast. So lightning static or from lightning strikes, you do hear it, but it doesn't impact the QSO. And I know HF operators have often on low band stuff, you would hear a lightning strike. It would slam the AGC on your radio up to, to 40 over and then slowly decay, correct? That doesn't happen. And I even noticed that this morning on our QSO. So here we go. See it? I'm about here. In fact, I'm right there. That little green dot is my lightning map receiver. And here's the storm right over Lake Huron coming into Georgian Bay. And you can see a bit of stuff going on here. So we'll get rid of that. So let's turn on the audio, and I want you to just listen to what we're hearing here. Okay. My AGCT for 80 meters, see it? I'm about here. In fact, I'm right there. That little green dot is my lightning map receiver. And here's the... So what I hit the space bar, it's supposed to pause. I wanted you to listen to the quiet noise and how the lightning was just a little piece of static. So I'll roll that up again to where we are. And pay attention to that part. Then I'll just let it run to the end. We'll get rid of that. So let's turn on the audio, and I want you to just listen to what we're hearing here. Okay. My AGCT for 80 meters, let's see, is way too high. Let me turn off my audio. Or we'll turn this down. If I adjust my AGCT just down, you'll notice it gets really quiet. But you go, I'm not going to be able to hear anything. Let me turn this. No, I'm going to turn this level up to a normal level. And we hear that click. And that's the fast attacks dual AGC. Click on, click off. I'm at medium, by the way, not at fast, not at slow. So how does that translate if you want to listen to a couple of guys? There's a net here on 3755.
1718. Anyway, the one went into the silo, died from the gas. The other one went into, seen his brother floundering there, went in, and he died too.
So you'll notice we can hear, that's my buddy Chad, speaking, just rag chewing about whatever. And
plain as day, sort of like the winter on a quiet day. Yeah, it's not perfect, but man, it's easy to listen to.
Similar story. Silos are nothing to mess with. Matter of fact, a lot of people put signs on the doors, especially up high, not to get in there. And that's a shame. Thanks for sharing that with everyone. It's VE2HOG, and he's a farmer, so he knows what's going on. This is the Ontars net. Anybody like to check in before I have to check?
Makes sense.
Yes, it
Really
does.
neat. Yeah, it's pretty impressive. By the way, I've got a screen pop up in front of me. If you're using Windows, go buy Windows Pro. It's like spend the extra whatever, only because on my remote station I have this big blue screen. It says we have an update for you. Do you want to put it on now or later? Of course, with Windows Pro, you can defer your updates. So just keep that in mind, so you're not, on Windows get the let's update on you in a hurry.
Michael, quick question. Do
Mhm.
you happen to have any recordings that show, say, down here in Georgia or in Florida or somewhere else in the South, in the middle of summer thunderstorms on 75 meters at night? Do you have any recordings there that shows like before and after? I think that'd be a great tool.
I do
to
not.
demonstrate.
But I'll ask Lou and 2TU to grab me some though.
Okay.
We're not a whole lot similar, or a whole lot different rather, but yeah, that'll be cool. A couple other things, by the way. So we have people have written programs. The advantage of what we call the API, you can write a program to connect to the radio. So we have SWR plotter 6K, SWR plotter 6K, which allows to turn the radio into a poor man's antenna analyzer. So you can sample every 20 kilohertz and at least build a sweep of a particular antenna. And for me, I use that. In my case, this picture was for my 160 meter vertical. Now up here, because the ground freezes, as the ground freezes, the resonance of the antenna rises. And I either have to tune it or go out about 11 feet of wire to the big inverted L to get it to come back down. And I just do that as a reference. Slice Master is an add-on tool. These are free. That it makes it incredibly easy to configure WSJTX. And it's literally a couple of mouse clicks. FR Logger is a flex logging program that talks to the radio. And there's more. There's many. So I've mentioned a couple of times regarding WSJT and digital modes. You do not have to buy any extra hardware. It's all built in. We use, in this case, a tool called Slice Master, and you can run multiple slices and receivers. And you've also got less points where you have RFI injection issues, cleaner signal, cleaner transmitted signal. You don't have to worry about RFI. And if you really want to learn more, we're on social media like most people. Now we actually try to keep it clean in a family channel. And so we have our help desk is online. We have Facebook enthusiast or Flex Radio enthusiasts on Facebook. And we have, if you're interested in talking more, you can reach us on sales phone numbers or emailing us directly, and we answer all those. And our community is amazing. It's focused on Flex Radio products and such. Pretty happy with how that's worked out. And that's it. So we lost the here they come back. We lost the clubhouse, I guess, or the community center. And I'm open to any questions or anything else I can show you.
I guess I'll bite. I have a question here. This is this is Dave W3DJS. I noticed that you have Windows and Macintosh clients. What about those of us who like Linux and Android?
This is an excellent question. I'll give you the hard message first. So Flex Radio won't develop anything for Linux and Android. However, there's a reason for that. The radio is wide open. The APIs, the commands we use to get data from the radio to set frequency to get the audio are published wide open. There's a whole wiki on how to do that. The iOS apps were written by two different people pretty much in a couple of weeks for basic functionality. Now we've approached the Linux crowd. The Linux crowd's getting there now, but we've approached the Android crowd that are ham operators and said, look, what does it take to get going on this? We want them to develop their own. Part of the reasons we won't do it is because of sheer economics and the staff and the requirement to run it and support it on the back end, especially in the Android world, because we would have to support so many different types of phones and carriers. And it would be scary on, somebody calls from Germany on Orange and says, yeah, I can't get Smart SDR for Android running, and we have no way to test it or debug it. So this is why we've reached out to the Android community and say, guys, hey, if you write it, we'll help you. Do you need access to a radio? Here's the instructions and how to get going. And I've been on forums with them, and I don't know if there's not enough ham operators that write software for Android. Somewhat the same for the Linux world, although in our Flex community, there are Linux people. They're now grinding away and developing a Linux app. And it's a bit of the same thing when it comes to post-sale support and revenue. We have to pay staff to take calls and stuff. So it's not a revenue generator, sort of a nice to have. I know it's sort of a blunt, dark answer, but I wanted to be honest with you and tell you that's the real reason. So,
I appreciate that. Actually, a quick follow-up question. Has anybody tried Smart SDR with Wine on Linux? Does it work
they've
with
tried.
Wine?
I think somebody, and you can find this on the community, I think somebody actually got it working with Wine. It should, usually what happens on these, when you start running in virtual machines, is there's just some physical port tunnel that doesn't work well, and that usually brings it to his knees. If you can run .NET on 9, then you should be able to get Smart SDR working.
Gotcha. Thank you.
Based.
Thank you.
A lot of Apple people run Windows in a VM as well. And think about it, about 95% of the amateur world is running Windows. The other 5, although incredibly vocal, may be running, 4 may be running Macintosh stuff, and they're pretty vocal, and that's great. And the same thing for the Linux world too. But eventually we'll get there. Somebody will wake up one morning who's retired, got lots of money, really smart, and he might write a Chromebook client because he can. That would work. So hope that helps, Dave. Sorry, I don't have the good news you want to hear.
No, that's fine. I just wanted to hear whatever the answer was. It's all good. Thank you.
Okay. And if there's anything you want to see, or you can obviously tell me later. If I put you to sleep, you can tell me now. If I had too much information, I'm always looking for feedback, especially at the crowd level, at the club level, because it's often hard to tell based on levels of experience where we're providing information. So, or what level. And I can go into the weeds or keep it really high level. I think the key point to take away is software defined is going to be the next technology. And we're only, from all vendors that are, if they stick around, are going to have some pretty cool stuff.
Michael, I just wanted to raise a question regarding the history of Flex. I've had a Flex radio since the 3000, and used to really love it because every time you issued new software, it was like getting a new radio. There was a lot of new features coming out. Is that still happening now? Or are we kind of reaching a saturation point in SDR, or what? How do you view?
That's a great question. And thanks for asking that. Have we reached saturation? Not by a long shot. Are we going to see a new radio on the 6000 series? Yes, we are. New software, for the radios. So here's what's happened. Over the last 2 years, we were approached and bid on a contract with the U.S. Air Force to replace the radios in the Air Force. That took a lot of time and money to develop that. And we're just at the end of it and waiting to see if we get the final contract, which we hope we do. In the meantime, now we're starting to come back and develop the amateur. And as things have, creeped along, we required more and more resources. So we had to steal more people away from amateurs. So for my Flex customers who've been with us for a while and haven't got their new radio, so to speak, update in a while, we apologize. Painfully aware, in a way, though, had to go where the money is, and that was the revenue for the Air Force. And it's sort of like Collins went through this too. They'll be back. So Gerald popped into our call, a call I had earlier today with a bunch of new hams, and we'll get there. And for that, and love your loyalty. And I also had a 3,000 and 5,000, and still have a 1,500. We'll see more, because the 6,300 of the early radios is still current radio. We'll still write software for it. It'll still do new stuff. I gather, and I'm guessing at some point in time, we may not be able to do that because it may not just have the horsepower, but time will tell.
That's my current radio, actually.
6,300?
Yes, sir. Love it.
Yeah, and you be the first to admit, you're as current as somebody with a new 6,600, other than the bandpass filters.
Right. Thank you.
Okay.
Thanks for the presentation tonight. It was very good.
Oh, you're welcome.
Michael, we only had one more request from the room here. We just wondered if you'd give us a little better view of that T-shirt.
Oh, we've got a bunch of them. So this one is, which one did I wear? Making Waves, Find Everywhere. We've got some Moon Bounce ones. I don't know if we actually put them on the store. We were giving them away for a promotion for something else, for QSO Today, actually, because we're a major sponsor for the QSO Today Expo. But I think we'll have more coming.
All right, well, thanks, Michael. I appreciate it. This a very good talk. Looks like the interest, there's no one, everyone's in full attention and paying attention. Maybe it's that $100 bill I'm waving, I don't know, but so appreciate it. Thanks for joining us, and we'll hope to see you again sometime in the future. I know I've gotten a Flex radio about a year and a half ago, and I don't spend as much time as I like, but it is a fun learning tool, and it's just amazing of the capabilities that these little things have.
Right. Well, let me show you one more thing, if you don't give me another 2 minutes, and if that's okay.
Sure.
Okay, here we go. I've got the right screen. You're seeing a shack control thing?
Yes.
So Dave WO2X and I wrote an article for QST Magazine on Node-RED. This is how we do our remote control. When I started doing remote years ago, I was tired of having 7 different applications open, one for relay switches, another one for a watt meter, another one for the rotator controller, another one for that. You get the idea. I had to have all these apps, and they, some of them took huge amounts of screen real estate when we didn't have huge amounts of screen real estate like we do today. So if you if you get QST and saw Dave's comment on Node-RED, this is my remote shack control. Now I've got it big so it's easy to see, but this is a PC I have at my remote station, and I connect to it remotely. I use, in this case, it's remote desktop, but I use it for contesting. I do all my contesting here, and so I can turn off a whole bunch of switches here. We can see that there's actually 2 clients connected to the radio. This doesn't format perfectly, but it's just informational for me. I control fans with Node-RED, which runs on a Raspberry Pi. You can see on my antenna controller, this is the 2x8 antenna switch I talked about. I've got one slice on 80 meters and another one on the stepper, which I know is on 20 meters, because I can look here and I can see it's on 20. And this is my stepper control. Rather than steppers software control, I can, change it and go do a 180-degree shift with it. A whole bunch of different things. And this is what Node-RED gets you. Now, normally, because I'm limited on real estate here, I'll shrink that down to something like this, maybe a little bit bigger, resize the screen. And I'll show you what, I think Dave's looking with interest at Node-RED. I'll show you what the Node-RED programming screen looks like. I call it like wiring, hardware wiring or software wiring for hardware people type of thing, because it's all about, it's a machine-to-machine thing, control. So, which is something we do a lot with in amateur radio, because we have frequencies and stuff. And I'm just waiting for the control panel to load, so I'll share one more screen one more time, and it's
I know I really appreciate that because it does take up a lot of real estate. I like the KISC, keep it simple and condensed.
Right. Okay, and you're now seeing a whole bunch of cool boxes. So
Yep,
this is
yeah,
this is a Node-RED programming screen. Well, heck, for us, this is a schematic. Most of us can read schematics. Let me find something simple. So, and I'll make this a bit bigger. So this is a web switch, simple web switch. It's actually sitting at the base of the tower. And these things are buttons on the dashboard we saw, and all it says, if I push the button once, send the HTTP command the switch, which is nothing more than, you know, the IP address of the switch and some funny string, and turn the switch off. Okay, and then the other one's on. So this is like, okay, we understand schematics. Now you can get a little carried away, but I'll make this smaller again. That's actually not a good example. Let's go to the stepper. So this is the control. This is all the control for my stepper. And I don't have, if you own a stepper antenna, which is designed to be tuning, you don't want to be transmitting while it's tuning. So, you know, I have the ability to put a gate in here right in the middle and say, don't send a command to the stepper to change frequency if I'm in transmit. If I reach over here, you see underneath it says open. If I put the radio, and I just hit the MOX on the radio, it said close. So any commands like a standard wiring gate get blocked. So that's sort of the thought process behind Node-RED. If you can do schematics and you're a bit logically thinking, you can actually code in Node-RED. And I can write hello world in about 11 different software languages, and that's it. But Node-RED works for me. And so a lot of stuff has also been written already by other people. So if you wanted to get involved, we have a group.io page, and hey, you want the Node-RED control panel for a KPA 500, it's already done. We'll share it with you and teach you about it. So that was what the article on QST was about.
Well, appreciate that, Michael. Kevin, is there anything else you want to add, or anything that you'd like to else say?
No, other than that, my heartfelt thanks for Michael to come on board here and give this presentation. It's really very, very interesting, especially for somebody who only has my little STR receiver, but really understanding a lot more of the inside outs and of stuff of software defined radio. And
Oh, yeah.
very
And
fascinating.
I predicted years ago to myself that once we ever got processors up at about a gigahertz, we would start seeing more of this. Sure enough, here it is. Michael, thank you for being with us and sharing your knowledge on this.
You're more than welcome. And the FPGAs, and we're going to see so much more. And thanks. I see the room applauding. I appreciate that.